So hello and welcome in this video, and in today's video we are going to discuss Taylor's theorem. Okay, we are going to discuss this Taylor's theorem and for two variables. Okay, so this is the expansion of two variable function in terms of Taylor's theorem. So the primary requirement uh, for the expansion of any function of two variables, let's say fxy is a function which is of two variables. So we have to expand this in terms of Taylor's expansion. So the primary requirement is same, that this function should be differentiable, and means this function should be continuous, plus its derivatives are also continuous. Okay, so function should be continuous, its derivatives are also continuous. So these are the basic requirement, and suppose we are giving this function fxy, and suppose we have to expand this function in terms of Taylor's theorem. Okay, in terms of Taylor's theorem or Taylor's expansion. So what we will do, we again take the first case, which is like if you are expanding in the close vicinity of the point xy, which are our general point. We are not putting any fixed or certain value for these x and y. So the expansion is fxy plus, now we know that because we are dealing with a function of two variables, and we know that for a function of two variables we have two first order partial derivatives. So the first one is with respect to x plus k times del over del y, which is the first order derivatives of this function f. Okay, now the next term will be 1 over factorial 2, okay, h square. Now here we are having three second order partial derivatives. Okay, so this is 1 over factorial 2 h square del 2 over del x square plus 2 hk del 2f over, so this is the mixed second order partial derivative, means you are differentiating this function f with respect to x as well as with respect to y, and lastly we are having del 2 over del y square, and we will put here this function f. Okay, so let's here we have to mark a change. So this f should not be here. Okay, this f should not be here. So this is how we can expand, and of course the next term are the higher order terms for this Taylor's expansion. Now some particular cases or some particular types of this Taylor's expansion. So if you are putting x is equals to a and this y is equals to b, then you will have you are in a two dimension, you are having the coordinates as x comma y. So now we are putting a fixed point, which is our a comma b. So now we will have this as f of a plus h and b plus k. So this should be again f of ab plus h times del over del x plus k times del over del y, and we have to find out the first order derivatives just as we discussed in the previous case, but here we need to find out the values of these first order partial derivatives at the point AB. And of course the next will be the second order derivatives, so we can write this as h times, in short you can also write the second order derivatives as like this. Okay, so we have to find out the values of these second order derivatives at the point AB. So this is the particular case of the Taylor's expansion about a certain fixed point. Now some particular case, in particular we can put A is equals to B is equals to 0. Means what we are doing here, we are considering this point A comma B as 0 comma 0. So now you can expand this function, means any given function. Okay, so this will be the case when you will obtain the expansion of any function in terms of the powers of x and y. So if in the question you are asked to expand a certain two variable function in terms of the powers of x, so all you need to do, you just need to expand that function about this point, means A is equals to B is equals to 0, or you can say the origin. So this will be the value of the function at the point 0 0, plus we have to find out h del over del x plus k times del over del y, and of course the first order derivatives of the function f at the values at 0 comma 0, plus we have the second order derivatives, so that will be h del over del x plus k times del over del y whole square of the function f at the point 0 0, and so on, some higher power terms of some higher order derivatives of the function f. And this expansion is known as the Maclaurin's expansion. This is very much similar to the case of one variable, where we are also obtaining this Maclaurin expansion after expanding the given function about a particular point, which is x is equals to 0. So now next we will discuss about certain examples. So our first example is, we have to expand the function, okay, expand the function fxy, which is given as e to the power x cos y about the point 1 comma pi by 4. Okay, so we have to expand this. So let us begin with the solution for this problem. Here we are given a fixed point. Okay, so we will if you compare this with the point A comma B, so you can easily obtain that the values of A as 1 and the value of B as pi by 4. So now we are coming back to our step, which is this expansion of this function. So our fxy is given as e to the power x cos y, and my suggestion is that in case of two-dimensional expansion, you should go up to second differentiable second derivative terms, means the terms containing the second derivatives of the function f. Okay, so that will be good. Now we will find f dash xy. So now, because this is not the case of one variable function, so what we have to do, we have to represent this first order derivative, means with respect to which variable we are obtaining this. So suppose we are doing del f over del x. So this is the partial derivative of the given function with respect to x, which is coming out as e to the power x cos y, and now the second first order derivative will be this is not y, in fact this is f. Okay, so this should be del f over del y, so which is coming out as minus e to the power x sin y. Okay, and similarly we can find out del 2f over del x square, so which is the second order derivative of this, so which is again same, means e to the power x cos y. Now next we will obtain the mixed derivative, means del 2f over del xy. So in order to obtain this, what we have to do, we have to differentiate this del f over del x with respect to y. So from here we will obtain e to the power x sin y, and we will next obtain the we have obtained the first second order derivative with respect to x and the mixed derivative. So we will next we have to find out del 2f over del y square. So what we have to do, we have to differentiate del f over del y with respect to y again. So this will be e to the power x cos y. Now what we need to do, we have to find out the values, okay, of these of this given function and the derivative of the function. So this gives the value at 1 comma pi by 4. So this will be e over root 2. Okay, so this is our first value. Now we will find out del f over del x at 1 comma pi by 4. So this is coming out as again e to the power e over root 2. Now next we will find out del f over del y at 1 comma pi by 4, and from here what we will obtain, we will obtain the value of this del f over del y will be minus times e over root 2. Next we will find out the second order derivatives. So this will be del 2f over del x square, and the value is at 1 comma pi by 4. So this is minus e over root 2, and next we will find out the derivatives. The next derivative is del 2f over del x del y, and the value at 1 comma pi by 4 is minus e root 2. Okay, so these are the values, and lastly we have to find out the value of this del 2f over del y square at 1 comma pi by 4. and the value of this derivative is coming out as minus e root 2. Now what we will do, we will put all these values in the expansion, or you can say the Taylor's expansion, and we will get our required expansion. So this will be fxy, okay, will be what we are getting. We are getting the value of the function at this point plus, now the main important thing is what we will take as our value of h and k. So that is simply x minus a, so that will be the value of h, and y minus b will be the value of k. So here we will obtain h times del over del x, so that will be x minus 1 del over del x plus y minus pi by 4, and this should be with respect to y f, and of course the value of this at the point 1 comma pi by 4, which we have already obtained. Last term is 1 over factorial 2. Now what we will do, we will take this as x minus 1 del 2 over del x square plus x minus 1 y minus pi by 4 del 2 over del x del y plus y minus pi by 4 whole square, and the value of del 2 over del y square. Okay, so this is we have already calculated all these values here. Okay, we have already calculated all these values here, so we just need to use these values. So now our function fxy will be the first one is the value of the function at the point itself, means 1 comma pi by 4 plus h plus k del over del y, and the values of, and similarly for higher order terms. So now we just need to put the values which we have already calculated. So from here we will simply obtain this expansion as the expansion as f of xy will be f at 1 comma pi by 4 plus x minus 1 del over del x plus y minus pi by 4 del over del y, and of course we have to find the values, and same we have to do with the second order derivative. Okay, so this will be x minus 1 del over del x plus y minus pi by 4 del over del y f, and of course the square of this. So after putting all these values here, we will obtain this expansion as e over root 2 plus x minus 1 del f over del x. So the value should be e over root 2 plus, next we are having y minus pi by 4, and the value of the function or the derivative of the function with respect to y is minus e over root 2. And similarly we will calculate this, means this should be x minus 1 del 2 over del x square, x minus 1 whole square del 2 over del x square. So this will be x minus 1 whole square over factorial 2 del 2f over del x square. So the value of the second order derivative of this function with respect to x is minus e root 2 plus we are having x minus 1 y minus pi by 4, and the value of del 2f over del x del y, which is minus e over root 2 plus we are having y minus pi by 4 whole square, and the derivative, the value of the derivative will be minus e over root 2. So this is how we will obtain this Taylor's expansion, right? So what we have to do, we have to just find out different values here. Okay, the values is very important, and sometimes we have to use different formulas. So means the derivative, how we can calculate the derivative means the formula of the differentiation. So that will be very important for this particular topic.